I'm going to speak for a little bit here. We're going to do introductions, and then we're going to break out into the presentation with Shoshana, and then we're going to have another exercise where you're going to do groups based on the discussion with the presentation from Shoshana. We're going to ask you to think of questions to talk about within your groups at your table, and then we'll collect that information and synthesize it. I know it's a big word for me too, but we're going to calculate all those findings and put those together and help, as you've probably kind of figured out, City of Ann Arbor, the SEU is trying to ask you contractors and suppliers and pipe layers and designers how to make this program work. And we've all learned from the past where if you don't engage the contractors and the people doing the work from the get-go, these programs don't seem to work so well. So it's really great that Missy and Shoshana have asked you folks for your input and feedback. So please, we already did one of these with the solar storage folks, and it really, any question or, even as you're sitting there listening to the presentation, jot it down in your journal or notepad, and please ask it in your group or ask it when we have a Q&A after Shoshana's presentation. So it's really important, and other people may not have thought about it, so it's really important to get your input. So first of all, can we go around with the internal team and do some introductions? Let's start with, let's start with Shoshana.
Everyone, I'm Shoshana Lenski. I'm the Executive Director of Ann Arbor's Sustainable Energy Utility. I'll be speaking a lot later, so I won't say very much now other than I've been in this role it's coming up on about 7 months now, as the utility is, of course, itself brand new. Before that, I spent a couple of years at the University of Michigan with a Sustainability Research Center, and before that, I spent 12 years at DTE Energy in a variety of strategy and gas operations roles. So I'm delighted to be here with all of you. Thank you.
Hi, everybody. I'm Missy Stoltz. I'm the Sustainability and Innovations Director for the City of Ann Arbor. The SEU is an idea that we came up with, and then we were like, hi, Shoshana, would you like to take it? So any anger that you have should be directed at me, and all your creative energy should be directed at Shoshana. And with that, I'm going to turn it over to our IMEG team.
Hi, I'm Adam McMillan, Director of Sustainability with IMEG. So I've been involved in this project for about 2.5 years through the early concept design phases, which we'll talk about a little bit more, and just really excited about the opportunity here and to be a part of it.
Morning, everyone. Taylor Gertz with IMEG as well. I'm sort of late to this project. They brought me on to help implement this, in charge of leading the design process as we go through construction.
Yeah, and I'm Walker Jones, also with IMEG. I'm IMEG's geothermal designer, or lead geothermal designer for IMEG. So I've been involved in the project from the start, looking at all the potential for geothermal systems on the site.
Thanks, Walker.
Good morning. I'm Martha Campbell. I'm with Michigan Saves, and we are partnering with the SEU in terms of how we are going to finance this effort, both for the SEU and potentially for some of the participants in the SEU. So I'm the Chief Program Officer, really happy to be here with you all today. We'll be also helping facilitate your conversations and collecting your feedback on the SEU.
Hello, my name is Julia Canine. I'm a program manager at Michigan Saves, and I'm here to also help with facilitating the discussions.
Hi, my name is Nishat Kaleem. I'm Director of Programs at Michigan Saves, and also here to help facilitate the event and the breakout discussions.
Hi, I'm Mac McCabe, Senior Partnerships Manager, and also here to help facilitate.
Thanks, Mac. We have one more guy over here, Aiden. We just want to make sure.
Thank you. Good morning, everyone. My name is Aiden Bourgeot. I'm the Management Assistant for the Office of Sustainability and Innovations at the City of Ann Arbor, and I just want to thank you all for coming today, and I'm very excited to get this kicked off.
Thank you. So now we want to know who you are, and we want to make sure we keep this rolling, so just please, as we go around, just say your name and company you're with, okay? So how many of you are well drillers? Raise your hand. Can you please introduce yourself?
Ken Thompson, the Midwest Geothermal. Quentin Callio, Midwest Geothermal.
Any other drillers? Okay. How about pipeline and distribution? Please intro.
Scott Wolf, I'm Vice President of Corby Energy Services. Bob Smith, Senior Construction Manager, Corby Energy Services.
Okay, thank you, welcome. How about HVAC folks? Okay, let's start over here.
Hi, my name is Matt Underwood with Michigan Energy Services.
Christine Wolfert with Michigan Energy Services.
Thomas Poole with Michigan Energy Services.
Gary Scheller with Running Right Heating and Cooling.
I'll throw myself in there. I'm Kyle Wisenkamp with Oak Ridge National Laboratory.
Okay. Anyone else from Oak Ridge want to do an intro right now? Oh, okay. How about consulting and research? That's all right. I didn't give him my categories ahead of time. Anyone else consulting research? Okay, how about anything else that I missed? Let's start over here.
Rick Humphreys with Salas O'Brien, Project Development, Financial Investment.
Great. Anyone else over here that we missed?
I'm Rob Self. I'm with DTE Vantage, a regulated subsidiary of DTE Energy.
I'm Eric Douglas, I'm with SEAL.
Eric McDonald with Walker Miller Energy Service.
Shantonio Birch with Thermoforce. We do research and development and thermal storage. Pleasure name with Someverse.
I'm Aisha Decker with DTE on the regulated side.
Bob?
With Energy.
All right. And we have Al Waller coming in a little late, but that's good, Al.
Al Waller with Water Furnace.
Thank you. And who's this?
Miles.
Miles. Okay, Miles. Did I miss anybody? Any shy person that didn't want to raise their hand or anything? Oh. I'm sorry, Diana.
I'm Kim. I'm here with 2030 Districts.
Great. I see you two over here. Come on.
I'm Lucas. I'm with OSI's AmeriCorps program.
I'm Sarah, and I'm also with OSI's cohort.
And these folks are going to be taking notes of stuff that's happening too, so thank you for doing that.
Let me just start saying thank you so much to everybody for coming out here today. It's amazing to have this large group of folks representing so many different sort of industries and activities. And as Todd said, we can't do this without y'all. So I am just, I'm going to talk for a little bit, but mostly I want to hear from you today. So hope this will be very conversational and yeah, looking forward to hearing your feedback. Okay, so I am gonna just start with a quick introduction to the SEU. Hopefully everybody had a chance to either attend the webinar that we did for contractors, gosh, I don't remember when it was, a couple of months ago, or watch the recording of it. But I'm actually gonna reveal, for anybody who might have missed that, we have a brand new video out, just released today, that will give you a quick 2.5-minute sense of what the SEU is.
In Ann Arbor, we're proud to be building a better future. But when it comes to our energy systems, we're stuck in the past. That means we're inheriting age-old problems. Power outages, polluted air, and ever-increasing bills for electricity and gas. But it doesn't have to be that way. The City of Ann Arbor's new sustainable energy utility is ready to deliver. Modern, renewable, local energy from rooftop solar, batteries, and geothermal heating and cooling sourced from the ground are proven technologies and are available. These modern systems can withstand climate change, disruptions to the grid, and are affordable too. So, how does the Sustainable Energy Utility, or SEU, work? Residents and businesses in Ann Arbor can sign up for this optional utility service. We'll help you determine the right solution for your needs, considering rooftop solar panels, an energy storage battery, or joining a neighborhood ground source heating and cooling system. We install these systems at no upfront cost to you. Simply pay a monthly rate for clean, green energy from the SEU. You'll stay connected to your current energy utility. However, you'll be using less energy from them, so you'll see a savings on your current provider's bill. The Ann Arbor Sustainable Energy Utility will own these energy systems, the same way other energy companies own power plants. So you're off the hook for maintenance. The Sustainable Energy Utility covers the upkeep. Ann Arbor voters overwhelmingly supported and authorized the creation of this thoughtful, first-of-its-kind municipal energy utility. This means, as a local, not-for-profit, the Sustainable Energy Utility belongs to you and prioritizes our community values, including equity and carbon neutrality. Your rates are invested back into service, operations, and, frankly, our planet, not lining the pockets of shareholders. What's more, we're your hometown utility, based right here in downtown Ann Arbor. The Sustainable Energy Utility is welcoming neighbor after neighbor and business after business to connect. Ann Arbor, you're invited to join. The future of energy lives here.
So we're a utility. As the video told you, we're a completely new kind of utility. There's no model for this anywhere, and there's no playbook for it, right? And so one of the things I want to say is that we'll share with you what we're thinking of doing, right? And you sort of got a sense from the video what we're thinking of doing. But I'm pretty sure that when we talk again in, let's call it a year, like things will be different than we're envisioning them now. We are a startup. We are trying things. We're going to learn from how they work. We're going to pivot. We might pivot some things by next week, and other things it might take a few years before we pivot, right? So I just want to put that out there and say, like, we are learning and building this plane as we fly it. And that's where I hope all of you will help be our engineers and mechanics and consultants and everything to help us through this process. So let me tell you a little bit about our geothermal system in particular, the planning for that. So first of all, I just want to be really clear that the geothermal system that we're talking about installing will be in the model of a utility, as a utility service, meaning it's going to be municipally owned and operated. So the city of Ann Arbor, our SEU, intends to own and operate this system and essentially invite residents and businesses to sign up. Optional, right? As we indicated, this is an optional utility. And then they would pay a monthly fee for the energy service. So they won't own the systems. They will be purchasing energy from the SEU just like they purchase energy from their current utility. It's also a supplemental utility, so this is really important. Those of you who obviously are familiar with municipalization, we're not trying to be a traditional municipal utility where we own poles and wires or we take over or replace the existing utility. We're intending to be supplemental. So folks will remain connected to DTE. I will say it's possible with our geothermal system and other sort of electrification options that over time some customers may disconnect from gas, but certainly will remain electric customers, you know, and again, this is only sort of if and when they fully electrify. For the geothermal system we're talking about here, we're intending to put the wells in the right-of-way or on public property, right? That's one of the advantages of us being a municipal utility. We don't have to ask people, unlike when they sort of do their individual geosystems, which I have one at my own house, right? And we tore up my driveway and put the wells in the driveway. You know, we're not asking people to install wells on their own personal property, so that will be in the right-of-way and on public property. So there will be the wells, the bore field, then we'll have distribution piping, and then service lines, and all of that would be the utility property. And then, of course, individuals will need to have heat pumps, appliances within their own homes. And we are still working on and thinking about and welcome your feedback on the approach to that in terms of where the ownership lies, whether the heat pumps will be owned by the individual end user or customer as sort of a home appliance, and we can offer on-bill financing for it, or that may in the end be a city-owned asset as well. Last thing is we are very likely to be billing at least residential customers sort of a fixed monthly fee based on their system capacity, right? So based on their heating tons or something of that sort. We've looked also at metering and variable rate billing, and I think that that might make sense, like BTU metering for larger commercial customers as we build systems that serve commercial users, but probably not worth doing at the residential side. So for those who are following what we're doing on the solar side, we are also intending to do fixed monthly rates for solar based on the capacity of the solar system that folks are putting in. So this will just sort of be consistent with that. So that's the framework for geothermal as a utility service. We will, by the way, be the first geothermal utility in Michigan when this is up and running. So we are preparing our first pilot systems, or first pilot system in the Bryant neighborhood, and that's the one that we want to, talk most deeply about today. Although, of course, we can also talk about how this expands citywide. For those who aren't familiar with it, we had some handouts of just describing a little bit of the history of the work that the city has done in the Bryant neighborhood. This long predates me, and Missy and her team have just done extraordinary work with the Bryant neighborhood, really resident driven, which is one of the things that makes it so powerful, is this was not sort of the city coming in and saying, hey, you guys, we think you should be carbon neutral. It was working with the city residents to say, what do you want this neighborhood to be? It's a very, very engaged community. I've had the privilege of just starting to get to know them in my recent months here. And they have committed as a neighborhood to becoming the most sustainable neighborhood in America and the first carbon neutral sort of existing neighborhood, right? So this is really different than building a new development where you can, it's easier to start off clean and fresh. This is an existing neighborhood with homes from the 1950s and all of this old infrastructure, and figuring out how to transition an existing neighborhood to clean energy sources and a lot of other work with it. So here's a picture of the community center. The Bryant Community Center has solar on its roof, and you can see a picture of a muddy day of drilling. It also has its own geothermal, and hi, Derek, the director of CAN out there. So really, really excited about the work with the Bryant neighborhood. All right, next thing about this project. So the wonderful, wonderful news is that the work is supported by $11 million almost from the Department of Energy. We are so grateful for this. Missy and her team again, and IMEG put in a huge amount of work to get this application ready for DOE and to make the case for why this is an incredible investment for the federal government to help support. That said, even with that, the economics are really challenging, and that's one of the things that I hope today we can have some conversations about and get some input from all of you on how we can make this as efficient as possible. Economics are always challenging, unlike the first of its kind, right? And there's some things that are sort of unique to the Bryant neighborhood that might make this particularly challenging. But so let me just tell you a little bit about it. There's the $11 million grant from the federal government. We're required to bring a match of that, like 100%, whatever we get from the federal government, we have to match. So if we want to be able to use all $11 million that the federal government is giving us, we have to bring a minimum of $11 million in match. As IMEG has designed the system, there's sort of, like modular components to it, so we can scale it in different ways. At a minimum, we probably need to spend about $15 million to get sort of like a viable system out of it. It doesn't make sense to drill like, a quarter of a well field or put in a quarter of a pump house, right? And so like as you look at sort of the economies of scale, we think like probably we want to do a system that's at least about 15 million. The full system design is probably in that $30 million range. And that would obviously be our ideal, is to go in and put the whole system at once, because these things work much better with economies of scale. So we've got obviously the capital that we need to bring to this, and if there's borrowing involved in the capital, then of course the interest rate is really important. in part because this is a project that takes a couple of years before it comes online, right? And then we know these are long-lived systems. Once we install it, it'll be operating for 50 to 100 years. So we'll recover those costs over a long period of time from the residents, paying their energy bills. But the interest rate matters a lot. So we are also looking for sort of thoughtful financing models that will allow us to, to get this at a reasonable interest rate. One of the other challenges here, obviously, as you can imagine, is that a fair chunk of the capital involved here, somewhere in the several million plus range, is for the actual HVAC equipment in 100 to 200 homes. And of course, folks tend to replace their HVAC equipment when it's at end of life. But as we are building a new system and it comes online, all of the equipment that gets replaced will be at various stages of its life cycle, right? Some folks might have a pretty new furnace or AC unit. Other folks, theirs will be at end of life. So it's just a little complexity in that sort of capital side for the heat pump equipment itself. The other thing to note, of course, is that our end-use customer is price sensitive, right? So this is a modest to low-income neighborhood in Ann Arbor. These are not millionaires who are like, yeah, I want to do geothermal and like I'm here to, do this no matter what the cost. These are folks who are burdened by their current energy bills, and part of what we're trying to do, along with solving climate-related issues and reliability and so forth, part of what we're trying to do is help them have affordable energy for the long term so that they can stay in their homes, so that they can help this neighborhood continue to thrive. And so they're price-sensitive customers. And of course, anyone who's from Michigan knows that we have some of the cheapest gas rates and most expensive electric rates from our utilities, right? So as folks are transitioning from gas heating to an electric heat pump, even though, of course, these are really high efficiency, there's still a challenge just to make that work. And then the last thing is, as I mentioned, of course, the SEU is intending to own and operate these assets for the long term, which means that we need to plan for the system O&M for the life of the assets, right? And some of that, there's ongoing just sort of pumping costs, like the energy for the pumping. There's obviously maintenance, and then there's sort of the utility administration and overhead, which I will tell you is very, very, very lean, but will need to grow if we're going to be operating a utility for 50 years here. So those are the challenges, and I am looking forward to you guys helping to solve it, because the flip side of that is like, okay, that looks really, really hard, and we might just sort of say like, too hard, we're going to walk away. We believe we can't walk away. The price of climate inaction is too high. Much, 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 much higher than the cost of all those other things we just talked about. And so not solving this is not an option in our minds. We are going to solve this, and we are looking for you to help us make this work and figure it out. And by the way, like, municipalities all over the country are watching to see what happens here. So what we can figure out and solve here can be replicated everywhere. Okay, that's my story, and I am going to turn it over to the IMEG team to now show you the actual system design, and you can start salivating over it or getting your questions ready.
Thanks, Shoshana. So we're just going to give a pretty high-level overview of the system as it's set up today. And, certainly as we go along today, we can dive into deeper details if we'd like to and whatnot. But kind of the high-level story of where this all began. So a couple of years ago when DOE came out with funding opportunity for communities to see how would a community-scale geothermal system work? How could we replicate it across the community, make it a utility, and show others how to do it? So their task was, there was some initial funding to think big, and then also, how can this be replicated? So those two things were in mind as we did that. And I actually see a lot of you in the room were a part of that too. So I know you've also had some input on this too, and I'm glad to see everyone is here as well. So when we initially looked at it, this neighborhood at Bryant, this was the focus for the study. So we envisioned that how would we serve this area up here to the north, There was also a site to the south which has public works and other facilities, so there was an overall concept to also connect to other commercial buildings, because these systems would work best when they can share energy with other buildings that aren't homes. So I think the long-term vision is thinking about how a community-based system could also hook into these other types of facilities in the future and make a really robust system. And I think that's still the vision for this. So we're setting this up to do that. So Walker will go through a little bit more on the distribution, but overall, it was how do we capture 262 homes in this initial phase with all these different loops that are up here. So that was the initial focus, with redundancy, with reliability, and with scalability in the future.
Thanks, Adam. So reminder, I'm the geothermal designer for IMEG, so it was my task to basically look at the community and try to figure out how we could find resources to use to get the BTUs that we need for the homes. So there were a few more properties around the neighborhood that we evaluated, but ultimately decided that the couple of park areas we have here in the center of the neighborhood and around the school made the most sense. We had the most real estate available, and it was kind of centrally located, so it sort of became a really good synergy for us. And so we're planning to drill, several hundred holes, about 200 in the main park, maybe 100 on the adjacent site. We were planning to have underground distribution, so we would tie all those wells together through a vault. We'd bring that back to a central pump station where we could then either distribute out to the community or just recirculate in, depending on what the call is. So there might be some days when we're just pumping around 2 homes, sharing energy from one home to the next. And there's certainly going to be times where we need a lot of BTUs out of the ground. We either put our excess heat into the ground in the summer for cooling, or we'll pull it out in the winter. Did you want me to go through more of the? So one of the other challenges was distribution, and I'll pass it over to Taylor here for a little bit to talk more about the distribution. But how we get that energy from the central park out to the community was also a challenge. And so we envisioned this, as we're talking here, like a utility system. So we envisioned this a little bit more like you have maybe for domestic water distribution, somewhat of a gridded network system where we'd have nodes where we could maintain reliability, effectively pump out of the central location to all the homes through various networks. And the initial phases of this job will be focusing on a few specific areas of this network, but long term we plan to get distribution to the entire community. And so here's that concept of the geothermal well field, bore field, well field. So again, we've got kind of the main park area. This P is kind of where we envision the pump house. That is still very much a fluid design from our standpoint. We're evaluating building designs and locations as we speak. The V's are basically vaults. So again, the idea, this rough representation of the wells that we would be drilling, and below the surface, about 6 feet below the surface, we'd have a whole network of pipes joining those wells together, bringing them back to these vaults. And then from the vaults, we would come back to the central pump house. This kind of purple line basically represents the main distribution loop that we would have. And then all the spurs that would go into the individual blocks and homes within the neighborhood would basically feed off of that spur. And we kind of color-coded those to make it a little easier to see. But, the various colors here basically just represent distribution out of this central network to each of the homes in the community. And then I'm going to hand this over to Taylor to talk about that distribution.
Thank you, Walker. So this gives you a zoomed-in look on what a typical distribution point would look like within the system. This is in one of our orange phase, as we call it. As you can see, the pipe sizes, they work from 6-inch coming from the well field and the pump house. And then as it gets distributed farther away and less demand, the pipe sizes decrease in size. So we're looking anywhere from 2.5-inch up up to 6-inch, perhaps even 8-inch pipe systems. And these are loop systems, keep in mind. So when you see a 6-inch down here, that's 2 6-inch pipes, right? Everything's in loop. With the idea that those systems, those pipes reside in the same trench, same bore line. And that's the concept at this point. Would love to hear if you think of something different or something that from a practical standpoint of installing those pipes makes a little bit more sense. So that's the typical distribution to home. This is a lot more engineered version of that, right? So if only we just had geothermal to deal with in the right-of-way, in the street, it'd be a pretty simple project, right? But we've got a few utilities we get to deal with. The first part of that is what does that look like in a plan view in the XY component? Staying within the right-of-way, minimizing disturbance to the street itself, right? These streets were repaved a couple years ago, so we're not just going to go in there and then install geothermal and leave the streets a wreck. We've got to come back and rehab those streets. How do we approach that as part of this project? Because those are certainly additional costs. We're dealing with wet utilities, storm, sanitary, water, but we also have gas, electric, communications. So it's pulling the needle through the haystack and then finding it on the other end here. The other component to that is, since everything else is already in the ground, we have to go deeper, unfortunately. So this is what a typical profile would look like. Here's our geothermal pipe, and it's 6 to 8 feet below the surface. It's below our sanitary sewer, which is typically the lowest. So there's some additional challenges there if we're talking about trenching versus boring. So all things that we need to think of and what the best approach there is. Now we look at it on an individual home basis or per lot. So here's the street over here on the left. We've got our utilities, other utilities, and then we've got our supply and return line for the geothermal. The envision is we have curb stops. This is the service line coming to curb stops that we can control, very similar to your water service. And then those service lines continue and go under the foundation of the house and up through the crawl space into the geo heat pump area. Obviously, we're dealing with other services, again, very similar to in the street or right away. We've got our natural gas, electricity, water, and our sanitary. So we're fitting put in a very tight spot, so there's going to be challenges with each lot, each street, and the neighborhood. We've gone through and done a subsurface utility engineering, or SU, another acronym for you guys, and we're identifying where all of those utilities are and obstacles. So when we actually get out into the field, we know where everything is, or at least we have confidence that we know where everything is. So I'm going to transition it to Adam here.
Yeah, and I think one thing too, we're talking a lot about the challenges with this project. I think, keep in mind, when DOE put out the solicitation, there were about 11 teams that were part of this, and it was a competitive process. So they were only down select a handful. And I really think one of the reasons our project got chosen is because we're tackling something really big and really hard. And I think if we can figure out how to do it here, they know this can be done anywhere else. There were other projects there that had fairly open sites, less challenging utilities. Imagine a new construction neighborhood, you could just trench it in, throw in your pipe, and you're done. So I think, even for the city, as it thinks about future neighborhoods, this is the perfect answer because we've been through the ringer and figuring it out here. We're going to know what to put into city plans for future things and other ways to scale this in the future. So, yeah, the challenges are real. This is a really tight street, as Taylor mentioned, but yeah, we're going to work through that. The other really big thing too, I think, on the previous slide, so I mean, we've done geothermal projects, we've done hundreds of them around the country. A lot of them are for individual buildings or individual homes. As a utility, redundancy matters, isolation matters. You know, that if this central utility has a disruption, you could take 50 homes offline from heating at a very critical time. So part of the network design has separate multiple loops that can backfeed one another. The two pipe is there for redundancy. So there is a lot of engineering thought going into how does this work as a utility, not just a single building in a single field. So even at the home level too, we have curb stop isolation, because if there is a single home that maybe needs, you know, some service, we can still run the rest of them on the street. So a lot of that thinking as we brainstorm today, think about how can we make it even more robust and more resilient as it goes forward as a utility. So then the last piece on the home, and I think a couple in your room went through these homes with us to start to figure out where can we put these units. So at a very high level, a lot of these homes have a centralized furnace in the middle of the home that's in a closet today. Most of them do have air conditioning as well. So there's an option where we could just replace it with the compressor inside the home as a single unit, as we show on the left. Or the other option would be to do a split system where we have just the air handler in the home connecting to the existing ductwork, and then there's an external condensing unit, which would make it easier from a maintenance perspective. So whether all homes need to go one direction for that maintenance reason or what the utility decides is still to be determined, but there are a couple different options, and different homes have configurations, but a lot of them kind of are set up in this way.
So let's talk about schedule. Right now, we just completed our existing conditions survey, identifying where utilities are, where the streets are, where the houses are, really giving us a good background for our design. We've started the design process. I would say we're roughly about 30% on the design process. Obviously, through the grant phase, we did quite a bit of work, but now it's the meats and potatoes of it here. As we work through the design, we're also working on procuring contracting, and that's where you guys come into play here. So at this point, we are approaching this as a CMAR, construction manager at risk. I don't know how many of you are familiar with that approach. That's a procurement move, pretty nationally known approach. What happens there is we bring in a contractor during the design phase to provide what we call pre-construction services. What does that mean? Well, that means you get to help in the design and you get paid for it. You become a partner in this project early and often, and we set up those relationships, and it leads to a lot of success for completion of projects. The second part of that is who better to give us pricing than the contractor. You know, we engineers, we try to claim that we know what pricing looks like, but we're not the experts. So we bring you guys in, we start throwing out options on paper, and then you say, no, that's a horrible idea, or yeah, I like where this is going, maybe do this. So include the contractor in those discussions for the designs and the standards for the design. It creates a great partnership with everyone involved, and ultimately leads to the success of the owner, which is the city. So CMAR procurement, we're going to start in the second quarter of this year. We're also working concurrently. We're not really sure how this is all going to fit. There's sort of three components here. We've got geothermal field, which Walker's talked about. We've got the neighborhood distribution, and then the third item's the homeowner service line and heat pump. So the CMAR contract may include any portion of those. We know for sure it's going to include the distribution system. We're considering including the geothermal field as well. If we decide to go with a traditional design bid build on that, that would also occur in the second quarter here. Our CMAR 50% plan set review is set for Q3 of this year. And that's a critical stage because then we hand the plans over to the contractor and say, give us input and give us a price. What does this look like? What are the hurdles? What are the risk registrations there? And then 90% plans, we're going to get a guaranteed, that should be maximum price, not GDP, and that's set for the fourth quarter of 2026. So that guaranteed maximum price is basically what the contractor thinks for the scope of work that we've shown, that they can have it installed, constructed at that price. So, and that's when the contractor will enter into a construction contract with the city. CMAR construction, we anticipate a notice to proceed of no later than Q1 of next year, with the anticipation that our first service line notice to proceed would be Q3 of 2027. So that's what the timeline looks like, subject to change. So we'll open it up for any clarifying questions, comments,
Yeah, and
feedback.
I'm just gonna we have, actually, I don't know what time it is. I didn't wear a watch this morning. We
It's
have
9:47.
Cool. We have like 15 minutes basically to do sort of clarifying questions, right, about the design, about how the utility plans to operate, and then we're going to have a guided feedback session for most of the next hour. So sort of the feedback questions, save those. Let's just stick to the clarifying questions now, and then of course we'll hear the feedback questions.
Yeah.
What does the final connection construction look like? Is that the heating contractor doing this, or is that something you guys are running lines into the house, or?
You're asking about when the contractor connects from the.
Lines in the street, and somebody wants to look up, what's their first step? They got to bring that into the house, obviously.
Sure, yeah, so we'll provide stubs, service stubs to each house, or not to each house, but in front of each lot within the right-of-way, basically at the, we're thinking at curb stops. Yep, yep, exactly.
And then would the HVAC contractor take it from there then?
Yeah, I mean, we're exploring several options there on what that might look like from that contracting standpoint. If it makes sense to have the distribution contractor do those installs, or if it is each individual lot is a separate contract.
Yeah, and maybe one thing I can just add from sort of a timing and process perspective is that before, our go, no-go decision on this, we will need to have a sizable chunk of customers signed up, right? And that sign up means that they are agreeing to become a customer of the sustainable energy utility. So we'll go when we have scale, but the system may go past homes that are not choosing to sign up at this time, right? And then there would be some later hookup process and a fee, right? So it'll be better for people to get in now. We're having a lot of conversations with the community and anticipate a lot of interest in participation, but that sort of the curb stop design will allow customers to hook up later in the process if they so choose.
And I would add to your point, we don't want to dig that hole twice. So that alignment needs between this contractor and the installing contractor needs to happen at the same time. So if those are both procured under the same contract, then that would be under the scope of the same general, I guess, and then that could be coordinated that way. If they were separate contractors, then we would need tight coordination on schedule to make sure those stubs can go where they need to go. So that's to your point, that's a pretty important piece of it. Any question there?
I had a question, if you could, you mentioned very briefly about the HVAC. If you could explain a little further about the two options. You mentioned one was a split and one I think was putting everything inside the air handler cabinet. And then secondly, do you have kind of the distribution of what is existing in those 262 homes? Are they all furnace AC or?
Yeah, so the majority are furnace AC throughout all the homes. And a lot of them are this same 1,000 square foot footprint. There are some other like mid-sized homes that have a little bit of distribution or different distribution, and some of those actually have a more dedicated mechanical room in the basement with even more space. So this kind of represents what I would say is the tightest condition for the homes. So in this case, most of them are more of this arrangement where there is just a dedicated furnace here with the water heater, and then there's an air conditioning unit, usually in the back, that's currently connected. So this option would be just to keep everything and the compressor within this closet, so it would all be self-contained with pros and cons to that. But we do think this might be the more common option to have a split system, so this unit is outside, so it's serviceable by a utilities representative outside the home, and then you would just have an air handler here, and then the refrigerant piping would go to this outdoor unit.
Are they mostly slab on grade or basement?
Yeah, it's crawl space underneath, yeah. So that's another piece too, with certainly freeze protection in the line and glycol and those considerations as well. But most of them do have, like what was in that other section of the home where there's a crawl space, you could get through that foundation wall, and then in that case you would come up through the floor.
Can I just chime in and say, well, first of all, this is Derek Miller. He is the Executive Director of Community Action Network. You can talk for yourself. Do you want to introduce yourself?
Sure. So as Macy said, Executive Director of Community Action Network. We manage 7 community centers throughout Washtenaw County, primarily in under-resourced neighborhoods. And so specific to this particular neighborhood, we have our Bryant Community Center that's already on its own geothermal. It's already been converted over. And we're actually 2 gas water heaters away from having it fully off of gas at that particular facility. It's also a resilience hub that has solar and batteries as well. And this geothermal design is actually part of a much bigger picture that I probably missed earlier. But it is I would argue, our last critical piece for the decarbonization journey that we have going on for this particular neighborhood. And we're well on our way on the other components as well. I don't know if I have much else to add on to that other than we're obviously very excited about this. This is one of those kinds of projects that you'd often probably find a lot of NIMBYism just because of how disruptive it actually is. But thankfully, through our planning process with the DOE planning grant that led to this moment, there was a lot of community involvement in that, and so it's not going to be coming at all as a surprise. We actually had a lot of engagement, a lot of excitement from residents, which we're obviously going to lean into because this is quite the project and quite the disruption as well. But we have a really solid foundation that we're actually building from for it. So excited to try to get this fully launched.
I just wanted to share, as part of what Derek said, this neighborhood itself was built by the same developer. There really are fundamentally 2 styles of homes, and people have done work over time, but there's a lot of consistency, right? So when you see this model, this is a very, very common, this is one of the 2 footprints you'll see. And the reason these 2 models came up, or these 2 designs, is because residents told us this is what they were looking at. They're very space constrained, they're tight homes, and so anything that frees up space was a desire, which is why we moved this way. So some of the things you may look and kind of scratch your head, but because it was resident-centered, we really did try to take their opinions, feedback into consideration as we thought about all elements. So I just wanted to put that forward.
Remember, clarifying questions because you're going to be at your tables talking about this stuff. So anything on your mind you want to clarify, now's the time.
How substantial are the heat losses and pumping losses through the distribution system relative to the total system capacity?
So, I mean, pumping losses, certainly. That was part of our evaluation of which pipe size to use to keep that reasonable. In terms of thermal losses, the distribution actually becomes part of the system. So those pipes buried 6 feet below ground do actually provide beneficial heat transfer into the system. Yes, sir?
How about flow control? How do you make sure each home has the right flow?
So like most modern hydronic systems, we're looking at a variable flow system so that we can kind of match the demand at any point in time. We can make, limit our distribution pumping energies that way. Homes would either have typical like on-off control valves, so when there's a need to cycle the unit, the valve would open. We would see a corresponding drop in pressure, and the pumps would react to that and speed up to make sure that we had adequate pressure for the neighborhood. An alternative is we could also have pumps built into each one of those residential units, so that they would effectively kind of, provide their own little lift to and from the distribution.
The minimum flow rate would be about 3 gallons per ton. So if you had a 2-ton unit in a home, you probably move about 6 gallons a minute.
Absolutely, that's correct. Well.
In the design, in the house design, is it anticipated that there will be duct modifications in the crawl spaces?
We weren't foreseeing that, no. I think our envision was that the existing distribution within the homes in terms of the duct and the air distribution would be reusable. It would be very comparable to the split AC system that most homes have today. And then, yes, sir.
Have you guys thought about like a clear connection procedure for the contractor that would, on a typical install, we flush that system out and eliminate any air? What's that plan moving forward in the district network?
That is one of the challenges. What we're planning is, a lot of these kind of nodes, as I mentioned earlier, we are planning on having isolation and flush ports there. So if we have more of a localized issue, I think it depends on, is this the initial build out? Is this the first 10 homes on the block, or is this that one home that wanted to do it 5 years later? So the process could be different depending on when it's going in.
Majority of those homes are of 2 similar floor plans that have AC units and all similar spaces. Would you see it being beneficial to take the stub-ups to those anticipated locations to limit excavation closer to the road to do it once? So that you can hit option 1 or excavate down and go in for option 2, being a one-time dig scenario, just getting it closer to the house.
I think that's a good thing to bring as options. I think as a utility, and then having it in the easement with that maintenance piece, I think would have to just make sure that it meets those requirements. But I see where you're going with that part of it for sure. Yeah. Yeah, and I think the other piece too, to the pumping losses, I mean, we do have a system with many spokes on a wheel, so that was intended to help bring down the pumping losses. And the other thing we didn't talk about either, those are black lines between some of the colored loops. Those are some lines that we could backfeed loops if there are issues with part of the pipes. We can put that redundancy in there as well. So those nodes become multi-purpose for a lot of reasons in that design.
Did I hear earlier that you're going to require a minimum of 10 homes on a block in order to plan for geothermal in that block or neighborhood?
Shoshana, do you want to take that?
Critical mass, I guess, is what
Yeah.
I'm asking, whether it be a neighborhood, whether it be the entire city. Has that been like?
Yeah, I know the DOE go, no go decision had a line item that was requiring scale, but I don't remember if it identified the number of customers. Missy, do you know? 100 total.
Yeah, and when we submitted the application, we had 50 letters of support. We couldn't get them already saying like we're in as long as this is cost neutral for us. So our anticipation is the best sales per citizen.
Yeah.
But we're stomping, we're on the ground constantly in the neighborhood, getting more and more support for the project. But I do believe we said 100.
Yeah, the green and the yellow loops on here were the first 2 that we were anticipating to install with that, and that's about 111 homes if they all signed up.
They talked us down from 111. Like, that's too specific, say 100. In a negotiation, too.
Yeah.
Yeah, and I'll just add one thing I realized I didn't share earlier when we're talking about the Bryant neighborhood, but as Derek shared, there's a lot of other work happening there, and this summer, 100 to 150 of these homes, of the 262 in this neighborhood, are going to get solar and storage through the SEU. So these are going to be our very first assets. We are deep in the procurement phase, and beginning in April, I think we're going to begin installation. So a very big chunk of customers, probably half the customers in this neighborhood will end up having solar and storage through the SEU. And we hope, of course, like that's going to be an experience that, you know, they'll get exposure to the SEU and the model of what we're doing and have a good experience and help drive adoption for the Geo as well.
So we're talking about a region of a 50-year time horizon and beyond. I'm curious, you know, what are we thinking about this to meet commercial needs, energy needs?
Yeah, I mean, I guess I'll say this neighborhood does not have commercial load in it, but the design, you didn't share the sort of the lower portion of it, but was designed with an anticipation that it could be connected up to another segment that would have commercial load on it. And our intent is, you know, this is a pilot, and we would like to build geothermal systems throughout the city, right, where we're capturing the commercial and residential load together.
And also Red Adjacent is Forest Hills Cooperative, so it's more cooperative housing, and they are also interested. We'll be doing a test while we're doing this geothermal there and in likely the neighborhood to see what options are available.
Just want to clarify, you had said it's a two-pipe system, but you said two-pipe for redundancy. It's not a one-pipe, it is a true supply return, correct?
Yeah, correct. Yep.
You mentioned briefly about the possibility of pumping through the distribution loop without pumping to the ground loop. Is there and you use the word vault, is there like a tank, a storage tank, or how does that all connect together?
Yeah, I didn't want to get too technical for the overall group, but the way that works, so let's say in the main park over here, right, we've got 200 holes. We may have 1 or 2 vaults. All we're really doing is just think about if we've got 100 holes, I'm going to group up maybe 10 of those together onto a common pipe. And all the vault does is it brings us to a common place where we can then consolidate that. So just think like little streets in the neighborhood merging onto the freeway. The vault's basically our freeway. It gives us an ability to phase the construction. So maybe we only need to do 30, 40, 50 holes at a time. We can connect those in. It gives us a place to isolate those. So if there was ever any issues, maybe somebody came back in and got careless with the backhoe and hit a line or something like that, that we could isolate parts of the system. And so the way the system would work, our vision is we'd have one set of pumps that pump to and from the homes. And we kind of have a target range of kind of high and low temperatures we'd like to maintain. And that when we start to get closer outside of that range, then we would start to introduce flow within the ground to temper it back down to the range we'd like to be in. In spring and fall, it would work very much that way, where there'd be times when maybe some homes are heating, some homes were cooling, there's not significant load. We'd kind of just be pumping water around the neighborhood, everybody's sharing that. But say this time of the year when pretty much everyone's heating, we would be circulating pretty much a complementary amount of water that we were circulating to the homes into the ground for heat exchange so we could bring it back at a more neutral temperature. Did that answer your question? Yeah?
So if you have other questions, please see the folks during the break. We're going to take a quick 10-minute break so we can come back at about 10:15.